Question 53 asks us to solve the system of equations using the equal values method. The reason why this is a little harder is notice that this one is in y equals mx plus b format. This one over here is not. The only way you can use the equal values method is if y is isolated, just like this equation, but in both equations. So we have an extra step, and that is we have to get y by itself here. So with this, understand that I'm going to isolate y by getting rid of all of this extra stuff. So we got to create a zero pair. I'm going to subtract 3x. But in order to do that, I have to subtract 3x over here. There's your zero pair. And I'm left with 2y equals, and then again, I want to write it in mx plus b format, so I would write negative 3x plus 9. Negative 3x plus 9. Okay, we're getting closer. I don't want two y's, I want y, so I'm going to split these into two piles. So that means I have to split all of this into two piles. So y equals negative 3 over 2x plus 9 over 2. Now, this doesn't look good, but we'll leave it like this. This is the other equation, and now I have y equals this and y equals that. So now I can set them equal to one another. 2 fifths x minus 5 is going to equal negative 3 over 2x plus 9 over 2. And again, we don't want fractions. So we see 5s and 2s, so we're going to multiply all the way through by 10. Remember, I'm doing it equally to both sides, so I'm good. 10 over 1 times 2 over 5x minus 10 times 5 equals 10 over 1 times negative 3 over 2x plus 10 over 1 times 9 over 2. Okay, simplify. 10 divided by 5 is 2, so 2 groups of 2x is 4x minus 10 times 5 is 50 equals 10 divided by 2 is 5. 5 groups of negative 3x is negative 15x plus 10 divided by 2 is 5. 5 groups of 9 is 45. Okay, next, let's get the variables all to one side. So I'm going to add 15x to the right, which means I have to add 15x to the left. I created that zero pair, which gives me 19x plus negative 50 equals 45. I'm now going to add 50 to both sides. 19x equals 95. And I'm going to divide both sides by 19. And x equals 5. Okay, but remember, solving a system of equations means that I have to find the place where the two lines intersect. So from here, I'm going to use one of the original equations, and in this case I'm going to use this equation right here. I can use either one of the original equations, and when I use it, notice that one of the letters is already solved for. I already have x equaling 5, so I can come up to here and go 2 fifths times 5 over 1. So I plug in 5 for x. The 5's cancel, and I get y equals 2 minus 5, which y equals negative 3. So my final answer is x equals 5 y equals -3, and I can write it as an ordered pair, x comma y. Now the last thing I should do is, since I already used this equation, I should quickly check it in the other equation. So I have 3x plus 2y equals 9. 3x plus 2y equals 9. And I now know what x and y are supposed to equal. So 3 times 5 plus 2 times -3, does that equal 9? So 15 plus -6, does that equal 9? Yes, it does. 9 equals 9, so it checks. That is 53.